In this video, we're going to look at how to solve exponential equations. So here's an example, 3 to the x equals 27 to the x plus 1. This is a group, this is a type of problem where the bases are either the same or that they are both powers of the same number. So here we have 3 and 27. 27 can be rewritten as 3 cubed, so we could make these have the same base. So I'm going to say 3 to the x is equal to 3 cubed to the quantity x plus 1. Now, this is where you have to remember your exponent rules. If I raise a power to a power, I multiply the exponents. So I can rewrite this as 3 to the x is equal to 3 to the 3 times x plus 1. Or 3 to the x is equal to 3 to the 3x plus 3. There's a lot of 3's in this problem. I didn't necessarily intend that to be that way, but that just happened. Now notice the bases are the same. If the left-hand side of this equation is to equal the right-hand side of the equation, then their exponents must be equal since the bases are already equal. In other words, x has to equal 3x plus 3. Or negative 2x has to equal 3. X has to equal negative 3 halves. If we check this equation, we can substitute negative 3 in for x here and negative 3 in for x here. Negative 3 halves in for x, both of these places, and we should get the correct answer. What I mean is we should get the left-hand side equal to the right-hand side. I wanted to show you a way to check this on the calculator that you might not have thought of. One way to do this is I can say to store negative 3 halves for x on the calculator, and then I can just type in my original equation. And you do want to use your original equation in case you've made mistakes on any subsequent steps. And I type in 3 to the x equals, and my equal sign is under the control here, equals 27 to the x plus 1, and it picks up those values for x that I just stored, and it says true. In other words, that's a true statement. If I use that value for x, this side equals that side. So that's a really good way to check. Okay, let's look at the next equation. Now, I can't write 7 as a power of 3, so I cannot use the method that I used here. So this only works if the two bases can be written as a power of the same number. So here I have 3 to the x plus 4 equals 7. I can do one of two things. I can take the log of both sides, or I can write it in log form and solve. So let me try, I'll show both ways. I can take the log of both sides, log of 3 to the x plus 4 equals log of 7. I can use the rainbow rule, which allows me, or the product property, which I call the rainbow rule, and bring the exponent out front. So I have x plus 4 times log 3 is equal to log 7. I can then divide both sides by log 3. X plus 4 equals log 7 divided by log 3, and then add 4 to both sides. So log 7 divided by log 3 minus 4 is my answer, and I can type that into my calculator. Now let me show another way to do that same problem, and I think I'm going to take this and just shift the whole thing over if it will let me do that. Let me try this again. Shift that whole thing over a little bit so I can write it again. So now another way to write this, 3 to the x plus 4 equals 7. I can say log base 3 of 7 equals x plus 4. Now, I've mentioned before that when your calculator is in press to test, it will not allow you to put in a base other than 10 or base e, the natural log. So we can get around that by using what's called the change of base formula. I can rewrite log base 3 of 7 as log of 7 divided by log of 3, or natural log of 7 divided by natural log of 3, either one. Then I can subtract 4 from both sides and I get x. So notice that's the same answer I got before. And I want to show you one other way of doing it, and that would be to take log base 3 of both sides of the equation. So log base 3 of 3 to the x plus 4 is equal to log base 3 of 7. You might remember your property that if these two bases are the same, then This simplifies to just x plus 4. Log base 3 of 3 to the x plus 4 is just x plus 4. You can also think about, I could bring the x plus 4 out front. Log base 3 of 3 is just 1. So this whole thing simplifies to x plus 4 equals log base 3 of 7. 3 different ways to approach it. You're going to get the same answer any way you do it, because notice we're back to this line again. I could find the decimal answer for this and plug it in, but I'm not going to do that. You guys can figure that part out. I would rather move on to a different problem. Okay, let's look at one now that has a base e. When you have a base e, you want to use the natural log. But this problem also illustrates something else. Before I use logs at all, I need to get the base with its exponent isolated. In other words, I need to divide by 4 first. So I have e to the negative 1.2t is equal to 5/4. Now use natural logs. I can say log base e of 5/4 equals this exponent. Log base e is natural log, so I can say natural log of 5/4 is equal to negative 1.2t. And then just divide both sides by negative 1.2, and I have what t is. Another thing I could do would be just to take natural log of both sides to start with, starting from this line. I could say natural log of e to the negative 1.2t is equal to natural log of 5/4. Using my product property or the rainbow rule, bring the negative 1.2t out front times natural log of e is equal to natural log of 5/4. Well, natural log of e is log base e of e, so this is just equal to 1. So that simplifies down to negative 1.2t is equal to the natural log of 5/4. Once again, divide by negative 1.2 and I can figure out what the answer is. When I get to this problem right here, 4 to the x plus 1 is equal to 5 to the x minus 3, this one gets a little more complicated, so I have made a separate video. So we're going to call this example 4, and there's going to be an example 4 video posted. So you'll look for the example 4 video for solving exponential equations, and I will do that one separately. Another thing we run into occasionally is equations as exponential equations written in quadratic form. There will also be a separate video for those. So these are your basic exponential equation type problems. Now sometimes you have to do a couple other steps to get them into this form, like maybe if this had been 3 to the x plus 4 plus 5 equals 12, I would have needed to subtract 5 from both sides first, something like that. But once you get the base raised to a power equal to a number, then use logs. Okay, so there you go.